outside pH measurement sensor or pressure sensor in raw steel plant, okay, in glass furnace unit or in steel melting shop or something. Then, do you think that these two environments are comparable? Is it? Hello, is it comparable? A sensor is developed and is installed in this office environment, and the sensor which is developed and installed in Rockdale Steel, some location within the plant. Is it comparable? Definitely not. Okay? So in industry, if you have visited, the amount of noise just because of these man-made components and products are so high that you require special casing, special arrangement, special pre-filters to avoid any possible of external injection or accumulation of noise. So you need to take special care for it. And if you are going to embed these technologies into it, so obviously things will become critical in terms of technology development and therefore the costlier as well. Okay? So you need to understand the requirement. Now I will come back to your topic. Let us proceed to the next slide. Next please. Next. Next. I'll take one case study. Next. I'll do this side. So now you see that this figure A, what you can see over here in the leftmost corner, is basically how many of you have seen substation? I'm not saying that visiting substation. Substation you have seen, okay, in the city environment, maybe outside the city, okay, a huge setup. So that's basically your open substation. Or in technology wise, you can say it's roughly around 60 year, 70 year, 50 year, 80-year old technology. Okay, what is very robust? Very robust. The foremost thing is very cost effective. If land is available, conditional, right? Now, if I will say that the land is available in the outskirts of Kurla and you require the same piece of land in the city like Bhubaneswar, I am talking about urban area. Then again, the cost is comparable? Absolutely not. In one case, maybe outskirts of Kurla, even I am not saying Kurla now. So maybe 10 kilometer, 50 kilometer, 15 kilometer away from this place, whatever the cost of land is available. Say for example, you require 2 acres of land, okay, or maybe 1 lakh square feet land. And the same space, if I want to demand or request from the government that provide me within the city, they will double your proposal. Why? Because is maybe that land cost within the Bhubaneswar city could be 100 times higher than that. Fine. So in that particular case, one of the applications we called gas insulated switchgear. Okay. I'm keeping it simple because my purpose is to show the mathematical model part. Okay. And before that, you need to understand that at each situation actually you require computational. That is my ultimate goal. What I want to share with you. So let us assume that these red boxes, what you see, vessels, what you see, is basically other than the transformer. You might have all of you might have seen. So primarily in the substations, that is we call the power transformers, PQ set, okay, as compared to step down transformer, which is fitted in your across your hostel or in residential. So it's a two different applications. One is a voltage transformer, one is a power transformer. So forget about that as a little. You take one transformer. So other than transformer, rest whatever things necessary arrangement you need to do so that the voltage, the desired voltage can be, the power can be supplied, I would say, to you, to us, to all of the end user energy consumers at desired voltage, at desired frequency. That is your ultimate point. So what we do here, unlike the open substations we have seen, in these cases, other than the power transformer, transformer is one exceptional thing. We keep it out. Rest all things are installed within these vessels. Idea is clear? Now, within these vessels, now when the system is open, what is the medium of insulation? Can anybody tell me? Air? Right? So air can be accessed in insulator. Now in this case, air is not going to work. Why? Because basically you are condensing the space. Understand? You are going to compromising the space. Now in this case, I need an insulation medium where whose dielectric strength is much higher Then that of the dielectric of the standard medium. That means the our reference is okay. Even I won't say vacuum, is a air. Yeah. So if you can do that, if you can manage that, the first advantage what you can get that you can miniaturize the size of device. Getting my point? You will get the same standard voltage rating, same current rating, same power rating, the desired one I would use the word, as compared to open substation with a miniaturized size of all those equipments are installed inside. Understand? Why you need it? Because if you are going to miniaturize, the biggest problem is the actually heat dissipation, heat transfer. Understand? You might have experience. You simply take an example of your smartphones. You compare the 5-year-old technology. Which one is now better? The latest one or the smartphone which you are using, which is manufactured 3 years, 5 years back? The older one. Okay. Nowadays things have become more and more compact. Still, you are not experiencing that heat problem. Why so? Because the technology has been developed to dissipate the desired amount of heat from the environment and with proper cooling mechanism. So that is something we are going to do here, but not with air. So the medium we have chosen is basically SFC. As on anything, you require a desired cost. That is for the operation cost. Plus, sometimes there is a maintenance cycle of each and every unit. It's a routine practice in any industry, including the power industry. Okay, so we call it O&M, operation and maintenance cost. Okay, so it has some boundaries. You have to spend that particular money. Okay, that means by the utility to entertain your end users. Because what entertainer wants, who are the entertainers? We people. We are the end user. We are the power consumer. What we want? We want a desired voltage, desired frequency. That is our requirement. Yeah. If there is a two utilities like your mobile phone today, right now you have no option in Kerala. You have a Tata Power. Earlier we called it best. Am I right? But tomorrow you think that if the Reliance is also there, okay, some state entity is also there, then you are going to purchase your power from which particular utility? Are you bound to any particular utility? No. Things is going to come. Things has been implemented in a metro city like Delhi, Mumbai around 10 years back. The day will time will come, maybe today, may not today, but maybe after 5 years, after 10 years, even a city like Sambalpur is also going to entertain with this kind of facilities. Yeah. But so when you have more than one utility, then it will be a real challenge, real business to play with the utility. Okay. So that is your benchmark. So remember what happened when we fix all everything installed inside the vessels, then your check process, that means the maintenance process become more complex. Why? Because you have to completely automate it. Okay, we nearly call semi-automation. That is something different. So we nearly automate. So to automate it, the first and foremost thing is that you have to gather the data. Okay, you understand? Okay. So to gather the data, how will you gather the data? You have to install certain sensors. Right? Now that is the starting of your measurement. That means you will pick some data. Make sure that you have picked the correct data. You have to make sure through your automation that sensors has transmitted the correct data and the correct data has been delivered to your destination. That means primarily your controller who is going to take certain decision. Because if you are delivering a wrong data, I'm not saying you are deliberately delivering. Let's say in between some noise is there, some disturbances is there, right? When you interact with your friends, sometimes your mobile strength gone down, right? So do you think that your service provider is doing it deliberately? So ultimately it's going to happen in business, but there are certain conditions, right? So where the maybe noise level is higher than the signal strength, so signal strength is automatically okay. So you have to make a necessary arrangement that the correct data has to be reached to the controller. Then your controller is going to reach. Now when it comes to the matter of controller, please be needed one thing. Use your all these complex computational methods, I would say. Okay, in power domain we call it power system optimization. The new buzzword is computational mathematics. Okay, use the computational, use some meta-heuristic technique like the Professor Huda said or other experts said. Only if your mathematical model fails. Okay, so I will give a very easy understanding of example. Let's say my objective is just to open and close the door. Get it? So how many states it has? It can have a number of states, but rest all are immaterial. One primary is either the door is open or the door is closed. These are the only two important things, right? Now, if you are applying the optimization technique to open and close the door, do you think that is it really needed? How many states you need to see? Two states. Can we apply a binary logic? Very simple, cost effective, robust. That is one option, right? Second option is that I will complicate the scenario. Okay, there are n number of permutations and combinations within the opening and the closing of the door. Therefore, I am applying some metaheuristic. Right? You are a researcher, you are free to do. Fortunately, we are in a democratic country. You can apply. Nobody can stop. So, is it needed in this case? No. So, please, I'm especially to our all bachelor students, to our PhD scholars, please formulate your problem correctly. That is the most important. And see that whether there is enough scope to apply these optimization technique or metaheuristic technique or not. Only if the mathematical model fails. Now, how do you know that the mathematical model fails? Primarily, as the system characteristic is being more and more complex, in that particular scenario, what you need to do that your mathematical solution will become more and more complex. That means the response time to govern that particular characteristic of the system will be increased. Okay, your response time will increase. Right? Now, you might have some desired limit. For example, there is an application in, like in this case, your data should be sensed by a sensor and it has to deliver to the controller, that is the master control center. Some big screens you might have seen, fancy screens. That is nothing to us, it is a human machine interface, we call it, right? Technically. So the data should be reached to the controller. It should be observed by some human personnel because we wanted to detect the industry. The requirement of to apply any metaheuristic technique or any optimization technique. Please do understand. But if your mathematical model is failed to entertain that, then there is a scope, that is the right place where you should apply these metaheuristic techniques. Okay. So, for example, in this case, what exactly happened? Please follow the next slide. Let's say consider the center of axis of this particular vessel, okay, and there is a surface, right? The outer surface, the two sides. Get it? Now, that's why I draw this particular curve. This distribution, what you see, is basically a temperature profile. What exactly happened? This vessel you see, the live conductors. Just can you go back to the previous slides? Okay. These pink colors you see, these all are the residuals SF6 gas. Okay, is filtered, right? Sulfur hexafluoride. So this medium insulation medium is now sulfur hexafluoride than that of air. Why? We will get better arc quenching capabilities and some other distinct thermal advantage, thermal properties. Next, now you see. So if the light conductor has passes through the center of axis of this particular vessel, where the temperature profile will be highest. Yes, you get the point. Your conductor through which you are supplying your current is basically passing through the center of axis of this particular vessel, inside this vessel. Clear? So in that particular case, the temperature inside the vessel will be uniform or will be non-uniform. Tell me, non-uniform. Where the temperature will be highest? Through the conductor, and where it will be the lowest relatively while I am moving from the radial direction, right, towards the surface. Clear? So the sensors was fitted, and remember, I am not criticizing. That is one of the most commercially successful sensor in the world. If you use the company Traffic, okay, it's GD402. Is nearly their market cap is roughly around 67% across the world. Not now, almost 7 years. Clear? When we consider this project to Ministry of Power, why they have given. So first and foremost thing they consider that the temperature profile is uniform. Why? Because they wanted to simplify their design. Okay, that point of time. They fabricated this sensor in 2010, and since one decade they are one of the market leaders in that particular domain. So first assumption they did that they consider the temperature profile uniform. That means basically they have neglected that unit. Yeah. Why so? Because their job is to measure the leakage, gas leakage. The gas is basically the vessel is completely filtered by the SF6 gas. Okay. Now the vessel pressure is relatively higher than that of the outside atmospheric pressure. So what will happen if some media is always filtered by gas? Okay, no technologies can commit that the gas leakage is absolute zero across the year. No one can even tell you. So there is certain standards which guidelines that per annum this much amount of leakage can be permitted. Like in case of this substations, the maximum limit is 0.5% per annum. I'm not saying 0.5, 0.5% per annum. So if your leakage is up to that limit, that is okay. Okay. Now what happened across the world? There it has been come to this is a very interesting story. Around 64 case studies. Okay, not much in India because this technology is being used from almost 4 or 5 decades across the world. So it has been around 64 failures has been reported. Out of which unfortunately 20 around 3%. I'm doing make it for simple 25%. So that means around every one failure out of four occur because of the sensor. Sensor is able to detect the leakage but very late. Now understand the technology. Okay. Why it detects late? Because it was using an indirect method of measurement. What do you mean by indirect method of measurement? What is the sensor job? Detect the gas leakage. Okay. How can I detect the leakage? Let's say this is a chamber which is filled by SF6 gas. So there is a leakage means what? Outside. So inside pressure is relatively high. If outside pressure is 1 atmosphere pressure, right? So if the leakage will happen, so and your automation is unable, your primary your sensor, because that is the first thing. If it is unable to detect within few desired amount of time, okay, some of the power system experts are here. You know that what will happen with the power system. Okay, the whole game is a matter of milliseconds. Cycle is milliseconds, not even a second. Second is a huge parameter for a power system. Okay, and the power is limited. So your entire system will collapse. Right? So that is the reason that why that transmission substation fails or basically trip. So trip means it is not participating into the system, into the activity. Okay, it detaches itself out. So that happens because of this particular reason. Yeah. Now, please move on to the next slide. I will circulate all these slides to you. If you have an interest, we can discuss in further. Don't hesitate. Go ahead, go ahead, go ahead. Yes. Move on, move on. I already told you. Next. Yeah, sit there. No, no, previous one. Huh? That is the one important slide I want to show you. So what exactly happened now here? So we wanted to examine that particular condition. We says that we are going to measure the density, we are going to apply a new mathematical model, and we are going to consider that particular limitation that the temperature profile is not uniform. It's non-uniform, so we are going to consider it as a non-uniform. But if you are going to consider it as a non-uniform, so any nonlinear characteristic will add the complexity into the system. What do you mean by that? Many times people say, add the complexity. What do you mean by that? If the characteristic of a system is nonlinear, so obviously to handle the mechanism, the circuitry, and that device combination will become more and more complex. So this is the reason that why the response time increases. Okay. Now, what is the ideal requirement? Your response time should be high or low? Low. Ideally, it should be zero, but we cannot make it zero. So I want some unit, some milliseconds, some microseconds, but it should be as minimum as possible. Am I right? Now, what we have done that we consider that the sound of speed. We take that particular vessel, give it a new sensor. We consider say, that the point from where the sensor is going to transmit, basically it's an ultrasonic sensor. So basically it is ultrasonic means a sensor which is operating at a frequency above 20 kilohertz. 20 kilohertz is your ideally audio limit. Okay, practically it is not 20 kilohertz even, it is roughly around 15 to 16 kilohertz. Okay, as a human, what we hear, we can, then it's deteriorate. Okay, there is a signal fidelity. But let's ideal range is 20 kilohertz. So your sensor is operating somewhere above 20 kilohertz. For example, this experimentation we have done at 40 kilohertz. So it's an ultrasonic sensor. Okay, now it has a transmitter, it has a receiver. So transmitter will transmit the ultrasonic signal. So that ultrasonic signal is going to hit the other side surface of the vessel, and then it will come back. Okay, you might have studied the Doppler effect, so kind of thing. So it will cover 2 times of the diameter. Okay, whatever the diameter of the vessel is, so it is going to recover the double of that particular distance. Right? So when it is going to reach that particular by the receiver, remember there is a pair and trans-receiver system. One side is transmitter, one side is the receiver. So when it will receive it back, in that particular time, it takes certain time. Some time, X amount of time. Let's say there is a X time. Right? Now if there is a leak, what will happen? What will happen? Density of the medium will change or not? Because there is a gas leakage. So suddenly phenomena is that the density of the gas or density of the insulator which is filtered in that environment will be decreasing. Now if the density is decreasing, tell me the time next time if I will transmit a signal, same frequency, so it will take less time to reach at the receiver or more time to reach the destination or receiver? Less time. Because density is decreasing. Understand? Are you getting my point? So if density is decreasing, then the velocity of the acoustic wave is increasing. So it will take less time. If there is a further leakage, what will happen? Now again it will take less time. Getting my point? So in earlier technology, what they did, they measure the pressure basically. And to measure the pressure, you know that there is a relation between temperature and pressure. Yes? Yes? अरे हाँ के ना तो बोल दो. Yes, na? I'm not going to ask any question. Don't worry. No single question. Okay? But we all know that the layman thing, there is a relation between pressure and temperature. In a controlled environment, if you are going to increase the temperature, your pressure will vary. If pressure is varying in a controlled environment, it will change the temperature. Right? So, what were the limitation of previous technology? They assume temperature is uniform. But actually, temperature was not uniform. It's a non-uniform. We consider this time is non-uniform. Okay, and let us play with that complexity. Okay, so altogether, what they did, they measure the pressure. Now, if you know the pressure of an environment, can you calculate the density? There is a formulation, right? Standard formula. Okay, you get it. This is the reason why that sensor takes more time to calculate the percentage of leakage, and this is the reason why the response time was higher in that case. So, by the time sensor detect the leakage, substation is in condition to outrest. Okay, it's failed. So by the time tripping mechanism, protective mechanism work, it detects that particular substation. Maybe some particular reason is okay. Blackout is a huge term, but some it is unable to supply that particular reason. Okay. Now in this case, what will happen? Our method was to directly measure that particular density. We are not concentrating on pressure. We will take the pressure as the one parameter. We will consider the acoustic wave. That means the response time as a parameter. We'll consider temperature as a parameter. We'll consider humidity also as a parameter because it can also change the propagation speed of acoustic wave. So we consider all these scenarios. Okay, that is C is basically the speed of the sound in an ideal medium first we consider. And then we know that because if you are able to, if you want to measure the density, which is a component of pressure, and as well as which is a component of temperature. Remember, the theta I in this case is basically the intrinsic temperature of the medium, okay? Not the phase. So theta is the temperature. And then we also measure that this particular gamma naught. So gamma naught is a basically coefficient, thermal coefficient, which is basically a part of the relative humidity. We substitute that particular value to calculate the exact speed of that particular acoustic wave if some percentage of leakage occurs. Okay? So in that particular case, if you simplify this particular equation, you know that if this square it will bring some order of nonlinear. Now what we want? We want a simplification of a model. How can we simplify the model? By avoiding a higher order of terms. If it is not put any major effect in your calculation, in your analysis. So for example, you are going to write down an n order equation where you have seen that in that particular application, if you are going to avoid third and higher order terms, then your calculation will be 98% accurate. Yeah? But if you are going to delete or erase or bypass that second order also, it is you are going to get around 90% accuracy. As an example, and these are mathematically correct. Fine. So now you see that whether in your application 10% error is okay or not, 5% error is okay or not, or you want higher accuracy, or the 2% error is okay or not. Okay, I give a very small example. I have given you a phrase, and that phrase is basically a combination of 100 words. Getting my point? Now let's say unfortunately two words I transmitted. Basically, I send you a voice message. That voice message is basically a sum of combination of 100 words. Now let's say because of any reason, 5 words were missing while it is being delivered to you. Can you guess those things? Possible? Up to some extent? If 2 words, 5 words are missing, if 10 words are missing, more difficult. If 50 words are missing, so that way you can understand the physical requirement of accuracy. Understood? Clear? So whether your response should be 98% accurate, 99% accurate, 95% accurate. Normally in industry we use two benchmark standards, 95% and 98%. Mathematically also you have said that particular thing. Clear? So we will apply all those things. We will apply a power series equation. This is nothing but basically a power equation of a Taylor series expansion. Okay, and then finally substitute in the bottom, you see what you will get. Where the contribution of this particular term is roughly around 0.005. Okay, not unit, 0.005%. So even if I will remove that, we count it because we wanted to calculate the exact value, and the exact accuracy should be more than 99%. Okay. Now tell me, in this case, do you need to apply? There was two approach. You straightforward put your standard equations, apply a meta-heuristic technique one way, maybe suited in some applications but not in all. Now in this case study, you had a two approach. Here, take n number of parameters, apply a meta-heuristic technique, get an optimal output. That is one way. Another thing, do some hard work initially. Okay, take the exact model. Do not compromise with the assumptions unless until it is very much not needed or mathematically cannot be justified. Simplify the mathematical model, reach to the final equation with the highest possible accuracy. Okay. Now what will happen? How many parameters you need to be? Intrinsic temperature, relative humidity, and that is ultimately a component of pressure. Okay. Over here, third equation you can see. Okay. So 3 inputs you are needing. Clear? So that is basically a power of computational mathematics. You can nearly model around 98%, 99% correct equations to draw or to understand the behavior of a particular system or the characteristic of a system. So characteristic of a system, behavior of a system, basically the same. Okay, it's a physical implication, nothing else. Yeah? So if you can do that, so this is the power of your computational mathematics. Okay, or to develop a correct mathematical model, which is the foundation of technology. Now, based on this, please proceed. Rest slides quickly. Okay. So these are the basically some application facilities, testing facilities. You can visit to our triple department automation lab. I can show you those things. Certain parameters. Here stands for time of flight. Okay. It is change in intensity. Please keep on going. Keep on going. Okay. That is the facility. Keep on going. More parameters analysis to justify the robustness of that particular developed sensor. Well, okay. So these are the things. Word. You can skip all this. Further, this is again the repetition of exercise to develop the humidity sensor. Go ahead. Move on. Okay. So you have to correctly select the some of the design is introduced by our team. It's basically a collaborative team. Some of the experts are in there. Some people here working here. Go ahead. Please proceed. All this. You can skip. So I think we are running short of time. Some 10 minutes or I should close. Fine. So, go ahead, go ahead. Yes. These all are enough developed technology, fortunately. Okay. Why the difference behind the foreign technology because that is one more application. Please go ahead. Pause. Next. Okay. That is one case study I will show you in terms of the system reliability, why it is important. So I will just explain you the physical behavior, rest I will say. That is a basically area in a thermal power plant where we have actually contributed. Okay. And that application was to develop the new control and instrumentation system, that means a complete automation platform, including the HMI for that kind of thermal power plant where the one prime mover size is around 200 megawatt to 660 megawatt. So in India, these are the standards 200, 220. Okay, it's not a variable size. Then 300, 330, 400, 440, 500, 600, and then 660. So we developed two designs. One is higher redundancy, that means above 500 megawatt. Low redundancy means anything around 200. Okay. So that was the actual area of contribution. But yeah. Next, the entire design was developed to so that the hydrogen can be supplied to that generating section uninterruptedly, irrespective of any challenge. That was the condition. That's the open problem. Go ahead. Okay, please stop here. This is the actual design. So remember, this is not even a generating section of a thermal power plant. There are so many things. Okay, tens of thousands of components within the generating section. Okay, within the generating section, this model was representing the necessary C&I or necessary arrangement to supply a pressurized hydrogen. Okay, for basically basically to dissipate the heat from the generating section, particularly in the stator casing winding. Okay, and for that you need to continuously supply the hydrogen to cool down the hot water, air or hot water. Okay, so initial cooling was done by water supply. Then the water is further cooled by this hydrogen. Okay? So remember, so it is hydrogen and then water. Yeah. So to develop that CNI, this is the only arrangement only for the that hydrogen cooling system. Words next. I'm not going to in depth. What this way? Previous. No. Next. Yes. Stay. So I'll just take consume one or 2 minutes. 1 minute. Okay. Now you see that RT is basically looking, but it is representing the reliability of a particular component. Okay. So it's a non-linear function. E raised to minus t by zeta raised to beta something. Okay. Let us not go to this volume representation. H stands for basically the failure rate. Understand? Now tell me one thing. In a class, there are two guys in a room. I would say in a hostel, you have a I think group of 2 3 people. Okay, staying in a room. Now imagine that there is a guy among of you who is highly unpredictable. Okay, so that means can I say that that guy has a poor reliability because you cannot predict what he or she will do, whether she or he will support or not, whether she or she will contribute or not, whether he or she will be participate with you or not. Okay, on a good care call, on a some leisure activity or something. So from your perspective, the reliability of that guy is poor or good or very high. Poor because it's unpredictable. What do you want? You want to associate with a guy with whom you can some sense of predictability, right? The same thing is with when you develop the automation platform, you design it for any industry application. If the reliability is high, that means rate of failure is chances of failure is low. I'm not saying zero is low. Understand? Now tell me one thing that in your team, which is basically a component of let's say is a combination of 25 people. Okay? Let me take that this is we meet here for one purpose, and you all are basically a team. Now, among of you, 3 4 guys will randomly going to create a noise. Okay, then what will happen? Or here the lecture is going on and someone is going to play the guitar. What will happen? Can you enjoy? Neither you enjoy guitar, nor you enjoy lecture by any means. Right? Huh? What happens? Because the mode of information is totally different. Playing of guitar, some different environment, some different activity. Okay? Delivering a lecture or listening a lecture is a different environment, different activity, so therefore different environment. Understand? So in that case, team effort is very great. Sometimes in industry, adding a one additional component in design may cost you even tens of crores of rupees, not lakhs, tens of crores of rupees. This design what you see previously is the cost is roughly estimated cost in around 2010-11 is around 847 crores. So with inflation now it has been reached to around 1500 crores. Okay, I didn't say 1500 lakhs, 1500 crore rupees. Okay, so every penny you spend, you are accounted. And here that if you say that sir, what happened? You are already spending 800 crore. You want to improve the reliability. What if one component is fail? Add one more component in parallel. If one will fail, bypass kar lenge. Very easy method, right? But if I am going to add the same philosophy everywhere, then probably your budget will turn up to 2000 crore in place of 800 or 2000 rupees in place of 800. Understand? So to model that thing correctly, mathematically, you will adopt this particular philosophy. Okay. Now, particularly in the power supply, we assume that basically the failure rate is constant. So there is a reason behind it. And this mathematics was basically outcome of a research. It's nothing new. Okay. But we need to satisfy that within the closed interval, whether the system can be considered with a constant failure rate or not. I said not, I didn't say zero failure. Constant failure rate or not. Okay, because if it is a constant failure rate, so that means you can very well predict it. And therefore you are in position to calculate that after how long time the system may fail. If you know this scenario, you can very well prepare your automation system to overcome that particular scenario. So this is actually whole philosophy. Okay, please proceed. So these are the certain models. Yeah. Please go ahead. Skip all these things. So in red, what you see that was actually outcome almost 10 years back. This is already we have already got one Indian patent which is applicable to 2052. It has been awarded to that problem. Please go ahead. Okay. So as compared to the previous, you can skip all this. So if you have any interest, any information, you can contact me. I can feed you the rest of the information. Like for example, this slide is it's not easy that this design HCL system will fail. Nobody claims that it will never fail. But to fail that HCL system, these many parameters should be met at the same point. Understand? So very difficult. Very difficult. So that's why the reliability was so good. 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 Please skip all this. You can skip. You can skip. So best life. Thank you. Right? If you are shy in nature, you can email me. I will be happy to answer to that. Okay? Thank you.
Thank you, sir, for a wonderful session. Now, I would like to request Professor Mohinder Kumar Jena, sir, to present a token of appreciation to Professor Dr. Gyanaranjan Biswal, sir. With this, we have come to the end of our third day of the 5 days workshop program. Thank you everyone for your practice, for your patience and kind support in making today's event successful. Hope to see you all in tomorrow's session. Thank you.
on time so that you can reset your answer in time. For it.